When you plunge into the deep ocean, you're not just exploring, you're battling physics. And today, we're going to talk about something wild: how the most common gas in our air, the stuff you're breathing right now, becomes a diver's biggest, most invisible threat. I mean, think about that for a second. What if the very air that keeps us alive could suddenly turn against us? Well, in the deep ocean, under all that crushing pressure, that's not a what if. That's exactly what happens. So every single breath you take is about 78% nitrogen. It's totally inert, just comes in, it goes out, we don't even notice it. Up here on the surface, it's basically just filler, completely harmless. But you take that same boring, harmless gas and drag it deep, deep underwater, and the entire game changes. That immense pressure transforms nitrogen into the root cause of two of the most famous and dangerous problems in diving. Okay, first up is the one most of us have probably heard of: decompression sickness, better known as the bends. And the most important thing to get straight right away is this is a problem that happens when you're coming up from a dive. So what even is it? Well, to put it simply, it's when nitrogen that was safely dissolved in your body suddenly turns into tiny, destructive gas bubbles. And the trigger? Coming up to the surface way too fast. The best way to picture this is to think of your body like a can of soda. Seriously, when you're deep underwater, the high pressure forces nitrogen gas to dissolve into your blood and tissues, just like carbon dioxide is forced into the liquid of a sealed soda can. Now, what happens when you pop the top on that can too fast? Psh, bubbles everywhere, right? That's the bends. If you ascend too quickly, the pressure drops suddenly, and that dissolved nitrogen fizzes out of your tissues, forming painful, dangerous bubbles right inside your body. And the result of all those little bubbles is, not fun. It can cause absolutely excruciating pain in your joints. That's actually where the name the bends comes from, because people would literally bend over in agony. It can also cause rashes and, in really bad cases, serious damage to your brain, heart, and lungs. It's a true medical emergency. But that's only half of the story. The other nitrogen problem doesn't happen on the way up. It happens while you're still at depth. It's a bizarre phenomenon called nitrogen narcosis, sometimes called the rapture of the deep. You see, under that intense, deep water pressure, the nitrogen gas itself starts acting like an anesthetic on your brain. It's not about bubbles forming. This is the gas itself, directly messing with your mental state, clouding your judgment and slowing down your ability to think. And this is where it gets really weird. The single best way to describe nitrogen narcosis is that it's like being drunk. And I'm not kidding, look at the symptoms side by side. Euphoria, bad judgment, feeling way too confident. A diver might start making really reckless decisions or feel totally invincible. Now, you can imagine how dangerous that state of mind is when you're 100 feet beneath the waves. Now, here's the critical difference. Unlike the bends, which need serious medical treatment, the effects of narcosis, well, they just disappear. All the diver has to do is swim up a little bit to a shallower depth. As the pressure decreases, the drunkenness just fades away almost instantly. So let's put this all together, side by side. Decompression sickness is all about nitrogen bubbles forming in your body, and it happens during a rapid ascent. Nitrogen narcosis, on the other hand, is the anesthetic effect of the nitrogen gas itself, and it happens while you're still at depth. Two very different problems, but they both point back to one single culprit: nitrogen under pressure. So, with all that going on, what's the simple, elegant takeaway? The one thing you really need to remember. This right here, this is the money shot. At depth, the high-pressure nitrogen gas messes with your brain. That's narcosis. But it's the rapid ascent from that depth that lets the nitrogen form bubbles. That's the bends. When you boil it all down, deep diving is fundamentally a nitrogen problem. And here's the ultimate rule of thumb to lock this in. Think about it. When you go up high, like climbing a mountain, the issue is a lack of oxygen. But when you go down deep into the ocean, the issue becomes too much nitrogen. It's a really clean, simple contrast that just shows how our bodies react to these extreme environments. Up high is an oxygen problem, down deep is a nitrogen problem. You know, it really makes you think. Our bodies are perfectly adapted for life right here at sea level, but just change that one variable, pressure, and suddenly a simple, harmless element of our air becomes a profound challenge. It really poses a fascinating final question. As we keep pushing the boundaries of exploration ever deeper, what other invisible threats and hidden biological rules are just waiting for us to discover?